Hello students, let's try to understand the Riemann-Tiemann reaction student. It is very important reaction of the phenol student with which what we prepared student ortho hydroxy salsaldehyde or the 2-hydroxy benzaldehyde you can say student, or the simply salsaldehyde. Student, how the reaction takes place that we have to understand. When phenol is treated with the chloroform, right, in presence of what, aqueous sodium hydroxide means what student, sodium NaOH and water student, at 340 Kelvin, followed by the hydrolysis and aldehyde group, that is CHO, get introduced in the ring at the position, what position student, to the phenolic group, that is ortho position student. So what the product is going to get student, ortho hydroxy benzaldehyde, or simply it is called salsaldehyde in the form as the product of the reaction. Why the ortho student? Because here it form the intramolecular hydrogen bonding, so it become the stable as compared to the para position student. So here you can see this is the phenol student. You are treating with the chloroform along with what you have taken student, aqueous NaOH. So it is going to give intermediate student. Again on treating with the NaOH, it is going to give unstable compound which giving in student aldehyde group attached along with the sodium phenoxide, which on acidic hydrolysis it is going to give student salsaldehyde. So let's try to understand the reaction once more student. We are going to write the equations, okay, so that you can understand very easily. Dear student, first of all what we can write student, here we are writing the phenol. So phenol is what student, OH group is directly attached with the benzene ring. Now you are treating with what student, chloroform student, CHCl3 student, CHCl3. Along with that what you are taking student, NaOH. So student, when you are taking NaOH, so what is happening student, out of this chloroform student, we can arrange this chloroform in the different manner also. So how I am arranging student, here is the hydrogen is there, this is the chlorine, here is the chlorine, and this is chlorine. So CHCl3. So one compound is getting released out student in the form of NaCl. So it is the NaCl out student, and hydrogen is going to be out in the form of water student. So here is minus H2O. So what is left student, what is left? So here only left the CCl2 student. This is it is going to attack on the ortho position student, right? So here you see student what the product you are going to get, dear student. So this is the OH group, okay, and since it is basic medium, so it will convert into ONA, and here is the CH, and this is the Cl, right student. Now treat with the 2NaOH student, 2NaOH, dear student. So if you are treating with the 2NaOH, so it is getting the out student, NaCl, and OH is going to attach here. So you can see here how the reaction is taking place student. So this is the ONA, sodium phenoxide salt, and here is it will be what student, CH, this side OH student, and here is also OH. Dear student, what will happen here, there will be the loss of water molecule student. So how the loss of water molecule, then what will be the you will get the CHO group is installed at the position of the second student. So here is ONA student, and what is left student, CHO, CH, and this oxygen CHO. Now you just do acidic hydrolysis student, you know, HCl you can take student. So this NaCl will be out student, minus NaCl. This how NaCl student, this Cl is there, and this Na is out student. So H will be, okay, taking place student. So what is there student, this is the OH, and here is CHO student. This is what the compound is called, simply it is called salsaldehyde, SALICYL aldehyde student, salsaldehyde, or you can call student the aldehyde group is the functional group. So 2-hydroxy student, you can say that is benzaldehyde. So this is our required answer student. So this reaction is all about Riemann-Tiemann reaction. It is very important for board exam student.